Quick trick. Speed equals distance divided by time. Welcome to our math adventure. Whether you're a young learner just starting out or an adult looking to brush up on essential skills, this video is for you. Let's begin with number systems. First up, we explore natural numbers and whole numbers. Natural numbers are the basic counting numbers, 1, 2, 3, and so on. When we include 0, they become whole numbers. Next, we move on to integers. These include not only whole numbers but also their negative counterparts, such as -3, -2, -1, and so forth. From measuring temperatures to understanding bank balances, integers are all around us. Finally, we have rational and irrational numbers. Rational numbers can be written as fractions like 1/2 or 3/4, while irrational numbers, such as pi or square root 2, have decimals that go on forever without repeating. Factors of a number are simply the numbers that can evenly divide that number without leaving any leftovers. For instance, consider the number 12. Let's ask, which numbers multiply together to make 12? We know that 1 and 12 go together because 1 times 12 is equal to 12. Try 2 and 6 because 2 times 6 is equal to 12. And then there's 3 and 4 since 3 times 4 is equal to 12. So, the factors of 12 are 1, 2, 3, 4, 6, and 12. Prime numbers. These are numbers that have just two distinct divisors, 1 and themselves. Fraction. A fraction represents a part of a whole. It shows how something is divided into equal sections. Imagine this chocolate bar. If I break it into two equal pieces, each piece is 1/2, 1/2. The top number, 1, is the part we have, and the bottom number, 2, is the total pieces. Percentage. Percentage is just a way to express a number as a fraction of 100. In simple words, it tells us how much out of 100. If you got 80% in a test, you scored 80 marks out of 100. Easy, right? Quick trick. To find 10% of a number, just move the decimal one place left. Imagine you have a mystery number, but you don't know what it is yet. In math, we call that mystery number a variable. We often represent variables with letters like x, y, or z. For example, in the equation x plus 5 is equal to 10, the x is our mystery number that we need to figure out. Now, let's talk about expressions. An expression is a combination of numbers, variables, and operations, like addition or multiplication. Think of it like a recipe where numbers and variables mix together to create something. Imagine you visit your favorite bakery every morning. Now, say the price of one cookie is a mystery we haven't determined yet, so we use a variable to represent it. Now, if the bakery sells a box of 5 cookies every day, we can express the total daily cost as an expression, 5c. This expression simply means 5 times the price of one cookie. If you later learn that one cookie costs 50, you can easily calculate the daily cost by plugging in that number. Imagine the simplest concept ever, a point. A point is a location in space. It has no size, no length, and no width, it's just a marker. Think of it as a tiny dot that says, I'm here. Now, let's connect points. When we join 2 points, we get a line, an endless series of points stretching in both directions. Imagine a road that goes on forever, beyond your sight. That's the infinite nature of a line. But what happens when we have not just a line, but a flat surface? With 3 non-collinear points, that is, points not all on the same line, we define a plane. A plane is a flat surface, like an enormous canvas for all our geometric ideas. Geometry begins to sparkle when we introduce angles. An angle forms where two lines meet at a common point, called the vertex. We measure angles in degrees, capturing how much those lines diverge. Building on these basic elements, we explore shapes. Start with the triangle, the simplest polygon, made of 3 sides. And then come quadrilaterals, circles, and many other shapes, each with unique properties waiting to be discovered. Imagine you want to put a fence around your garden. The fence needs to follow the outline of the shape, covering every edge. This total distance around the shape is called the perimeter. For a square or rectangle, you simply add the lengths of all 4 sides. Whether it's a regular shape or a complex polygon, calculating the perimeter tells you exactly how much boundary material you'll need. Next, let's talk about area, the measure of the space inside a shape. Think of area as the carpet that covers the floor of a room. For two-dimensional shapes, area is measured in square units like square meters or square feet. Each shape has its own formula to capture the space it occupies. The area helps us understand, for example, how much paint you'll need to cover a wall or how much turf to lay on a grassy field. Now, let's step into the third dimension, volume. Volume measures the amount of space a 3D object fills, like water in a swimming pool or air in a room. Unlike area, which covers a flat surface, volume measures the capacity of an object in cubic units, such as cubic meters or cubic feet. Ever raced against time to reach somewhere on schedule? Ever wondered why speed matters when traveling? The secret behind it all is time, speed, and distance, 3 simple but powerful concepts. Let's break it down. Distance is how far you travel. Time is how long it takes. Speed is how fast you're going. These 3 are connected by a simple formula: speed equals distance divided by time. Want to find distance? Multiply speed and time. Time equals distance divided by speed. Let's say you're riding your bike 10 kilometers at 5 kilometers per hour. How long will it take? Using the formula, time equals 10 divided by 5 is equal to 2 hours. The faster you go, the less time you take. Probability is the math of chances. Like flipping a coin, there's a 50% chance of heads and 50% of tails. The formula? It's simple. Probability equals favorable outcomes divided by total outcomes. So, if there are 3 red balls in a bag of 10, the chance of picking one is 3 out of 10, or 30%. Now, statistics is about understanding data. We use it to find the average, mean, the middle value, median, the most frequent value, mode, and the spread, range. Imagine trying to write this: 6,200,000,000. That's a lot of zeros. Now imagine doing that in every science problem. Exhausting, right? Scientific notation is a shortcut. It lets us write huge or tiny numbers using powers of 10. Here's how it works. You take a number between 1 and 10, in this case, 6.2, and multiply it by 10 raised to a power. That power tells us how many times to shift the decimal. Small numbers? Same rule. 0.00052 becomes 5.2 times 10. The negative power means we move the decimal 4 steps left. Have you ever looked at a ramp, a ladder, or the shadow of a tree and wondered how we measure angles and distances without climbing them? The answer is simple: trigonometry. Let's break it down. In trigonometry, we focus on right-angled triangles. The longest side is the hypotenuse, the side opposite the angle is, you guessed it, the opposite, and the side beside the angle is the adjacent. It helps us define our key trigonometric ratios. These are the backbone of trigonometry, our tools to calculate unknown sides or angles. Let's say your ladder is 10 feet long and leans against a wall at a 30 degrees angle. To find how high it reaches, use sine. These angles come up often. A good trig learner knows them cold, or at least keeps a cheat sheet. Meet their reciprocals. And yes, trigonometry comes with its own set of identities.